January 17, 1945, the Ardennes Forest, Belgium. The morning arrives without color. Snow lies thick across the Belgian countryside. Muffling sound, erasing boundaries between earth and sky. In a concealed position behind a shattered stone farmhouse, a Sherman tank sits motionless, its long barrel extending like an accusing finger toward the tree line. The crew inside can see their breath in the freezing air. They have been waiting for 3 hours. Through the vision slits, they watch the fog begin to lift from the valley below. Somewhere in that gray morning, they know German armor is moving. The tank commander, a lieutenant from Ohio named Robert Marsh, adjusts his headset and whispers into the intercom. His gunner replies with a single word, "Ready." The loader checks his ammunition for the 5th time. These are not the standard shells they trained with in England. These are 17-pound armor-piercing rounds, each one capable of punching through steel that American tankers once thought invincible. The Sherman beneath them is not the Sherman their instructors showed them in training films. It is something else entirely, something the Germans have not yet learned to fear, but they will. This morning, in this frozen forest, they will learn. When the war in Europe escalated beyond the initial German blitzkrieg victories, when the myth of invincible panzer divisions began to solidify into doctrine and terror, American military planners faced a crisis of metal and mathematics. The M4 Sherman tank, backbone of American armored forces, rolled off production lines by the thousands. Factories in Detroit, Chicago, and dozens of other industrial cities produced them with a speed that stunned the world. But speed of production could not compensate for a fundamental deficiency that became horrifyingly apparent in the hedgerows of Normandy and the fields of France. The Sherman's main gun, a 75mm cannon effective against infantry and fortifications, could not reliably penetrate the frontal armor of German heavy tanks. When a Sherman encountered a Panther or Tiger, the American crew faced a simple equation. The German tank could destroy them from distances at which they could not effectively fight back. Tankers developed grim nicknames for their vehicles. They called them Ronsons after the cigarette lighter whose advertising slogan promised it lit the first time, every time. They called them Tommy Cookers. The British soldiers who crewed American-supplied Shermans knew the statistics better than anyone. A Sherman typically had to score 3 or 4 hits on a Panther to achieve a kill. The Panther needed only 1. In the calculus of armored warfare, this disparity measured the difference between life and death, between mission success and catastrophic failure. By the summer of 1944, after the landings in Normandy, British tank crews understood they were entering battles in vehicles that could not compete on equal terms with the enemy's best armor. But wars are not won by resignation. They are won by adaptation, by the stubborn refusal to accept defeat as inevitable. In the workshops and proving grounds of wartime Britain, a transformation began that would alter the balance of steel and fire on the battlefields of Western Europe. It began not with American initiative, but with British desperation and ingenuity. The British Army possessed a weapon that could penetrate German heavy armor, the 17-pounder anti-tank gun. This formidable piece of artillery could punch through the frontal armor of a Panther at combat ranges. The challenge lay in mounting this powerful gun in a tank chassis that could keep pace with mobile operations. British tank designs either lacked the internal space for the weapon or remained trapped in development delays. The solution emerged from an unexpected marriage of British firepower and American mass production. Engineers at the Royal Ordnance Factory examined the Sherman with fresh eyes. They saw not its limitations, but its possibilities. The Sherman's turret, though designed for a smaller gun, possessed dimensions that might, with extensive modification, accommodate the 17-pounder. The project demanded innovation at every level. The 17-pounder's recoil force exceeded anything the Sherman was designed to handle. Its ammunition was larger, requiring reconfiguration of the turret's interior. The gun itself had to be modified. British engineers designed a new recoil system, relocated equipment, removed the hull machine gunner position to create space for additional ammunition, and redesigned the turret interior entirely. They even had to rotate the gun's mounting 90 degrees to fit it within the turret ring. What emerged from these modifications was a hybrid weapon system, a Sherman that carried the killing power necessary to face German heavy tanks on more equal terms. They called it the Firefly. The name itself carried an element of deception. a mundane designation for a weapon that would prove anything but ordinary. By early 1944, British factories began converting standard Sherman tanks into Fireflies at a steady pace. The conversion process was complex, requiring skilled labor and precision engineering. But it was far faster than designing and producing an entirely new tank. By D-Day, British armored units included Fireflies in their tank troops, typically one Firefly for every 4 standard Shermans. This ratio reflected production constraints but also tactical thinking. The Firefly became the unit's designated tank killer, the vehicle commanders relied upon when German heavy armor appeared. German tank commanders in the winter of 1944 possessed years of combat experience. They had fought across the steppes of Russia, through the deserts of North Africa, in the mountains of Italy. They knew Allied tanks. They knew the Sherman's capabilities and limitations as thoroughly as they knew their own vehicles. A Panther commander could identify a Sherman silhouette at extreme range, could calculate firing solutions almost instinctively, could maneuver with the confidence born from understanding that his frontal armor provided near immunity to the Sherman's main gun. This knowledge informed every tactical decision, every approach, every engagement. German doctrine emphasized using the Panther's superior gun and armor to engage Allied tanks from positions where return fire would prove ineffective. It was a doctrine proven effective through countless engagements. But doctrine built on knowledge becomes dangerous when that knowledge is incomplete. The Firefly looked like a Sherman. It moved like a Sherman, from a distance, through dust or smoke or morning fog. It presented the familiar silhouette that German tank commanders had learned to identify and engage according to established tactics. The visual differences were subtle: a slightly longer barrel, minor modifications to the turret shape, details that might not register in the crucial seconds of target identification during combat. British crews understood the value of this deception. They often added additional camouflage to the Firefly's distinctive longer barrel, shortening its apparent length to further disguise the tank's true capabilities. They painted the muzzle brake to reduce its visibility. Some crews went so far as to paint false markings on the turret, adding to the visual confusion. The first German tank commanders to encounter Fireflies in combat died without understanding what had killed them. They engaged what appeared to be standard Shermans according to standard doctrine, and discovered too late that doctrine built on outdated intelligence was not doctrine at all, but merely a path to destruction. A Panther that might have maneuvered confidently into firing position against a standard Sherman found itself suddenly facing a gun that could penetrate its frontal armor. The psychological impact of this reversal cannot be understated. German tankers had grown accustomed to a specific hierarchy of armored combat. They knew which Allied tanks posed serious threats and which could be engaged with relative confidence. The Firefly shattered these assumptions. A tank that looked like prey was actually a predator. The transformation extended beyond simple firepower. American engineers, observing the British success with the Firefly, began their own investigations into improving the Sherman's lethality. They could not replicate the Firefly directly. The 17-pounder was a British weapon, and converting American production Shermans to British specifications created logistical complications. Instead, American ordnance specialists developed the 76mm high-velocity gun, a weapon with significantly improved armor penetration compared to the original 75mm. Shermans armed with this gun began reaching frontline units by the autumn of 1944. While not quite matching the 17-pounder's penetration capability, the 76mm gun allowed American crews to engage Panthers with a reasonable chance of success, particularly when firing at side or rear armor. The statistical reality of armored combat shifted gradually through late 1944 and into 1945. Shermans still died in disproportionate numbers when facing German heavy armor, but the ratio improved. More importantly, German tank commanders could no longer assume that any Sherman they encountered was vulnerable. Every engagement carried new risk. That long-barreled Sherman in the distance might be a Firefly. That standard-looking Sherman maneuvering into firing position might carry a 76mm gun capable of defeating their armor. Uncertainty entered German tactical calculations, and uncertainty breeds caution, and caution slows initiative, and the loss of initiative in mobile warfare often proves fatal. In the Ardennes that January morning, Lieutenant Marsh and his crew represented the culmination of this transformation. Their Firefly had arrived in Belgium 3 weeks earlier, assigned to a British armored unit supporting American forces still recovering from the German offensive that had crashed through these forests in December. The crew had trained on the Firefly for 6 weeks in England before deployment. They had fired the 17-pounder on ranges, learned its quirks and capabilities, practiced loading its heavy ammunition in the cramped turret. They knew their weapon could kill a Panther. They had not yet proven it. The sound reached them first, the distinctive rumble of heavy German armor moving through forest roads. Marsh raised his hand, a signal to remain still, remain silent. Through his vision slit, he watched the tree line. Minutes passed. Then, emerging from the fog like a prehistoric creature materializing from legend, the Panther appeared. It moved slowly, cautiously, its commander scanning for threats. The German tank was positioned at an angle, its thick frontal armor facing Marsh's position. This was not an advantageous shot. The Panther's armor was thickest at the front, sloped to maximize deflection. A standard Sherman would have held fire, would have waited for the Panther to expose its flank or rear. But Marsh commanded a Firefly. He spoke quietly into the intercom. The gunner made minute adjustments. The Panther continued forward unaware. In that moment, the German commander was making calculations based on incomplete information. He saw farmhouse ruins, possible infantry positions, potential threats that fitted his experience and training. He did not see the Sherman concealed behind the stone wall, because Marsh's crew had positioned carefully, using available cover. Even if the German commander had spotted the Sherman, his response would have been calibrated to engage a threat he understood. He would not have expected what came next. The Firefly's gun roared, the sound massive in the frozen morning, echoing off hills and forest. The 17-pound projectile crossed the distance in a fraction of a second, traveling at velocities that turned hardened steel into a penetrator, capable of defeating the best armor metallurgy German industry could produce. The round struck the Panther's frontal armor at a slight angle, and the mathematics of kinetic energy overwhelmed the mathematics of protection. The shell penetrated. Inside the German tank, the round's passage created a catastrophic pressure wave, turned interior components into shrapnel, ignited ammunition. The Panther shuddered, smoke erupting from hatches, and ground to a halt. Marsh's crew did not celebrate. They were already acquiring a second target. Another Panther had appeared at the tree line, and its commander had seen the muzzle flash, was traversing his turret toward the farmhouse. But the Firefly's loader had already slammed another 17-pound round into the breech, and the gunner had made his adjustments, and the second shot followed barely 15 seconds after the first. This round struck the second Panther in its side armor as the German tank attempted to maneuver. Side armor was thinner. The penetration was catastrophic. 2 Panthers destroyed in less than 30 seconds. The remaining German tanks withdrew into the forest. They had encountered something unexpected, something deadly, and experienced commanders knew better than to press an attack when the tactical situation had turned uncertain. Those Panthers would report back to their unit headquarters. Intelligence officers would note the engagement, the apparent Sherman with unexpected capabilities. Reports would circulate, warnings would be issued, but the information would arrive too late for many German tank crews. The Firefly had already proven its effectiveness across dozens of engagements from Normandy to the Rhine. The secret, such as it had been, was fragmenting with each battle, each destroyed Panther, each surviving German crew's testimony about Shermans that fought like tigers. American industrial capacity had always been the Allies' greatest material advantage. German planners knew the statistics, understood that American factories could produce tanks at rates no German facility could match. But quantity without quality could be overcome through superior tactics and engineering. The Panther represented German confidence in quality. Its design philosophy emphasized firepower and protection over mechanical reliability and ease of production. Each Panther took longer to build than a Sherman, required more rare materials, demanded more skilled labor. But each Panther, German planners calculated, was worth 3 or 4 Shermans in combat. This equation justified the investment. It also created a vulnerability that German strategists failed to adequately address. The Sherman's fundamental virtue lay not in its individual capabilities, but in its adaptability and availability. The same chassis could be modified for dozens of roles: tank destroyer, armored recovery vehicle, engineer vehicle, self-propelled artillery. When British engineers needed a platform for the 17-pounder, the Sherman provided that platform. When American ordnance specialists needed to field an improved anti-tank gun quickly, the Sherman accepted that gun with modifications that could be implemented without completely redesigning the vehicle. This flexibility emerged directly from American design philosophy, which emphasized reliability, ease of production, and adaptability over specialized excellence. It was engineering democracy in metal form, and it proved devastatingly effective. German tank crews in early 1945 faced erosion of the confidence that had sustained them through years of combat. They still possessed superior individual tanks. The Panther's gun could still kill Allied armor at ranges where return fire was difficult, but superiority meant less when uncertainty clouded every engagement. Was that Sherman across the field a standard model or a Firefly? Should they engage immediately or maneuver for a better position? The seconds spent in evaluation were seconds when Allied tanks could close distance, could maneuver into flanking positions, could call in artillery or air support. Tactical initiative, once wielded with assurance, became tentative. The psychological dimension of armored warfare has always exceeded simple mechanical comparisons. A tank crew's effectiveness depends not just on their vehicle's specifications, but on their confidence in those specifications. Experienced German tank commanders had learned to trust their vehicle's capabilities to exploit the Panther's advantages aggressively. The Firefly introduced doubt into that trust. More insidiously, it introduced doubt retroactively. How many previous engagements had been with Fireflies rather than standard Shermans? How much of their tactical understanding was based on incomplete information? These questions had no satisfying answers, and in the absence of answers, caution replaced aggression. Hesitation replaced initiative. By February 1945, as Allied armies pushed toward the Rhine, German armored units faced enemies on all fronts with dwindling resources and diminishing options. The Firefly was merely one component of a larger system grinding German military power to destruction, but it represented something symbolically significant. It demonstrated that Allied industrial and engineering capacity could adapt and overcome German qualitative advantages. The 17-pounder gun had existed since 1942, but mounting it effectively in a mobile platform required engineering innovation, production capacity, and the logistical framework to field and sustain modified vehicles in combat. Britain possessed the engineering skill. America possessed the production capacity. Together, they created a weapon system that neutralized one of Germany's key tactical advantages. The recurring image of the Firefly's long barrel, disguised and deadly, became a metaphor for Allied material culture. German propaganda had long emphasized quality over quantity, the superiority of German engineering and martial spirit over American mass production and material abundance. The Firefly demonstrated that quantity enabled quality, that production capacity created flexibility to adapt and improve, that the ability to field thousands of platforms meant the ability to modify hundreds into specialized killers without compromising overall production. It was democracy's answer to dictatorship's myth of superiority. We can match your quality and overwhelm you with quantity. Simultaneously, American tankers who transitioned from standard Shermans to 76mm equipped versions or who crewed British Fireflies experienced their own transformation. They had entered combat knowing their vehicles were outmatched by German heavy armor. They had developed tactics emphasizing maneuver, numerical superiority, and avoidance of frontal engagements with Panthers and Tigers. These tactics worked, but they imposed psychological costs. No soldier enjoys knowing they are fighting with inferior equipment. The improved Shermans did not erase the technical gap entirely, but they narrowed it sufficiently to restore confidence. A crew that could engage a Panther with reasonable hope of success fought differently than a crew that knew engagement meant near certain death. The German perspective reveals itself most clearly in captured documents and post-war interviews. Tank commanders reported increasing caution when encountering Shermans, inability to distinguish Fireflies from standard models at combat ranges, and frustration at losing the tactical initiative that superior range and armor had previously guaranteed. One Panther commander captured in March 1945 described the shift. We no longer fought with the certainty we had known. Every Sherman became a potential killer. We hesitated, and hesitation in tank combat means death. This testimony, recorded by Allied intelligence officers, captures the reversal the Firefly represented. The hunted had become hunters, and the hunters had learned fear. The technical specifications tell part of the story. The 17-pounder could penetrate 140 millimeters of armor at 500 meters. The Panther's frontal armor measured 80 millimeters, sloped at 55 degrees, providing effective thickness significantly greater than its nominal measurement. But the mathematics of kinetic penetration favored the 17-pounder at typical combat ranges. The American 76-millimeter gun performed slightly less impressively but still represented a quantum leap over the original 75-millimeter. Numbers on specification sheets translated into destroyed German tanks, into survived engagements, into Allied tank crews returning from battle. The symbolism of the Sherman Firefly extended beyond its immediate tactical impact. It represented the Allies' ability to recognize problems and implement solutions faster than their enemies could adapt. German heavy tanks had dominated Allied armor through 1943 and into 1944. By late 1944, the Allies had fielded a response. German industry, strained by strategic bombing, resource shortages, and competing demands, could not match this pace of innovation and production. The Panther itself was a response to encountering Soviet T-34 tanks on the Eastern Front. But by the time Panthers entered mass production, they faced not just T-34s, but a growing array of Allied weapons specifically designed to kill them. The cycle of adaptation moved faster than German industry could sustain. In the final months of the war in Europe, as Allied armies crossed the Rhine and drove into Germany itself, the Firefly continued serving in British armored units. By this point, its existence was widely known to German forces, its capabilities no longer surprising. But knowledge without the means to counter it provided no relief. German armored forces, starved of fuel and replacement vehicles, fought a retreating defensive campaign with increasingly limited options. The Firefly had achieved its purpose not through surprise but through sustained effectiveness, through proving that Allied engineering could match German quality while maintaining overwhelming quantitative superiority. Lieutenant Marsh and his crew survived the war. Their Firefly destroyed 7 confirmed German tanks, including 4 Panthers and 2 Tigers. These numbers do not capture the full impact of their presence on the battlefield. They do not measure the German tanks that withdrew rather than engage, the attacks called off because Fireflies were reported in the area, the cumulative effect of uncertainty on enemy planning. Statistics measure destruction, but cannot quantify deterrence, cannot calculate the value of enemy hesitation and doubt. The Sherman Firefly remained in British service after the war, serving in Korea and remaining in reserve stocks until the mid-1950s. Its combat record secured its place in armor history, but its deeper significance lay in what it represented about Allied strategic culture. The ability to identify a problem, engineer a solution, implement that solution at scale, and field it effectively in combat operations demonstrated systematic advantages that transcended any individual weapon system. The Firefly was not the best tank of World War II. It was not even the best tank destroyer, but it was effective, available in useful numbers, and fielded when it was needed most. In warfare, timing often matters more than perfection. The German expectation of maintaining armored superiority rested on assumptions about Allied industrial capacity and engineering, flexibility that proved fundamentally flawed. German planners understood that America could produce vast quantities of equipment. They understood that British engineering was sophisticated and innovative. What they failed to grasp was how these capabilities would combine, how British innovation could be married to American production capacity to create hybrid solutions that addressed tactical problems faster than German industry could counter them. The Firefly exemplified this synthesis. British gun, American chassis, combined engineering from both nations, produced at scales that made a tactical difference. German soldiers at the front experienced this reality through its consequences. They saw their Panthers burning, saw their tactical advantages eroding, saw the certainty that had sustained them replaced by fear and doubt. The mythology of German technical superiority, carefully cultivated by propaganda and sustained by early war victories, crumbled under the weight of Allied material abundance and adaptive engineering. The Firefly was merely one hammer blow among many, but it struck at a critical point, neutralizing one of Germany's key advantages in armored warfare. The fog had lifted entirely by mid-morning on that January day in Belgium. Lieutenant Marsh's Firefly sat silent, its crew watching the forest where the Panthers had withdrawn. The two destroyed German tanks smoldered in the snow. Somewhere behind the Allied lines, intelligence officers would record the engagement, add it to the statistical archives documenting the war's mechanical violence. The numbers would show 2 more Panthers destroyed, 2 more data points in the vast calculus of industrial warfare. But numbers cannot capture what those destroyed tanks represented. The death of certainty, the erosion of doctrine, the psychological impact of discovering that the enemy you thought you understood had changed into something more dangerous. In the ending, there is always a truth that exceeds the facts. The Sherman Firefly story is not ultimately about tank specifications or penetration values or the technical minutiae of armor metallurgy. It is about adaptation, about refusing to accept defeat as inevitable, about the democratic principle that problems can be solved through collective effort and ingenuity. The engineers who designed the Firefly, the factory workers who produced them, the crews who fought in them, all participated in a system that transformed material abundance into tactical effectiveness, that turned industrial capacity into strategic advantage. They proved that free societies, when threatened, possess capabilities that authoritarian states cannot match: the flexibility to innovate, the transparency to recognize failures and address them, the industrial depth to implement solutions at meaningful scale. The German soldiers who died in burning Panthers never knew exactly what killed them. They died believing they fought in superior machines, died with doctrines and tactics that had been proven effective through years of combat, died without understanding that the war they were fighting had changed in ways their leadership could not counter. This was the Firefly's ultimate impact. Not the tanks it destroyed, but the certainty it erased. Not the German armor it penetrated, but the German confidence it shattered. In the end, that psychological victory mattered as much as any tactical success. The snow continued falling on the Ardennes that afternoon, covering the destroyed Panthers, muffling the sounds of distant artillery, erasing the tracks and scars of battle. By tomorrow, other tanks would move through these same forests. Other crews would fight their own engagements, and the grinding arithmetic of industrial war would continue. But in the turret of one Firefly, a crew from Ohio and Yorkshire sat together, sharing coffee from a thermos, speaking quietly about home and survival, and the strange lottery of combat that had allowed them to live while their enemies died. They did not speak of victory or ideology, or the grand strategic narratives that would later define this war. They spoke of simpler things, of warmth and safety, and the hope of seeing another morning. In their silence between words, in the steam rising from their coffee in the frozen air, in the long barrel of their tank, pointing toward an enemy they had learned to defeat, lay the truth of what free peoples could accomplish when their values were threatened and their ingenuity was unleashed. The Firefly was their answer, forged in steel and fire and the stubborn refusal to accept that superior enemy technology meant inevitable defeat. It was democracy's promise made manifest, that collective strength could overcome individual excellence, that adaptability could defeat doctrine, that freedom itself was worth fighting for with whatever tools ingenuity and industry could provide.